Analog and digital communications. Modulation is defined as the process by which some characteristic of the carrier wave is varied in accordance with an information bearing signal. With some characteristics of carrier wave is varied. Carrier wave characteristics అనేవి change అవుతాయి in accordance with the information bearing signal. Bearing signal means here message signal. The carrier is needed to facilitate the transportation of the modulated signal across a band pass channel from transmitter to the receiver. మన క్యారియర్ ఎందుకు సిగ్నల్ ఎందుకు యూజ్ అవుతుందంటే మాడ్యులేటెడ్ సిగ్నల్ని త్రూ ఛానల్ ద్వారా ట్రాన్స్మిటర్ నుంచి రిసీవర్కి సెండ్ చేయడానికి క్యారియర్ వేవ్ అనేది యూజ్ అవుతుంది. We'll study 4 linear modulation strategies that constitute the amplitude modulation family. Linear modulation strategies basically four modulation amplitude modulation family నుంచి ఉన్నవి. Amplitude modulation, double sideband suppressor carrier DSB-SC, single sideband SSB, vestigial sideband VSB. These 4 types of modulation differ from each other by virtue of their spectral characteristics. Here this is a message signal. మనం తీసుకున్న ఇన్ఫర్మేషన్ ఏదైనా కానీ మెసేజ్ సిగ్నల్ ఇది. Carrier signal is a high frequency signal. It is used to transmit the message signal. When we come to a modulated wave, here ఇక్కడ మనం గమనించినట్టయితే అకార్డింగ్ టు ద మెసేజ్ సిగ్నల్ క్యారియర్ సిగ్నల్ యాంప్లిట్యూడ్ అనేది చేంజ్ అవుతుంది. హియర్ ఇక్కడ మనం అబ్జర్వ్ చేసినట్టయితే అర్థమవుతుంది మెసేజ్ సిగ్నల్ అకార్డింగ్ టు ద మెసేజ్ సిగ్నల్ ద క్యారియర్ సిగ్నల్ యాంప్లిట్యూడ్ ఈజ్ చేంజ్డ్ అకార్డింగ్ టు ద మెసేజ్ సిగ్నల్. Here this is the amplitude modulated wave. Here it is the maximum amplitude. When we come to theory part వచ్చేసినట్లయితే మనం డెఫినేషన్ చూద్దాం. ఫస్ట్ ద amplitude of the carrier signal varies in the according with the instantaneous amplitude of the message signal. Carrier signal amplitude అనేది according to the amplitude of the message signal అనేది చేంజ్ అవుతుంది. ఇక్కడ consider sinus and carrier wave C of t is defined by the C of t equal to AC cos 2 pi FCT. AC is the carrier amplitude. Here AC is the carrier amplitude. FC is the carrier frequency. Frequency of the carrier. FC means M of t is the message signal. An amplitude modulated wave may thus be described as a function of the time as follows. S of t equal to AC into 1 plus Ka M of t cos 2 pi FCT. Where Ka is the constant is called the amplitude of sensitivity of the modulator responsible for the generation of the modulated signal S of t. Here we observe the diagram. K is the constant amplitude sensitivity in the AM modulated wave. Next, the carrier amplitude AC and the message signal M of t are measured in volts. Amplitude of the carrier signal AC and the message signal M of t are measured in volts. Amplitude sensitivity K is measured in volt inverse. Here the amplitude of the modulated wave S of t is AC in 1 plus Ka M of t. Here AC to 1 plus Ka M of t. This is the amplitude of the modulated wave. The envelope S of t has the same shape as the message signal M of t, provided the two conditions are satisfied. The amplitude of the Ka m of t is always less than unity. ఇక్కడ ఏమన్నా less than 1 ఉన్నప్పుడు the m amplitude is greater than for unity, the carrier wave becomes over modulated. ఇక్కడ మనం అబ్జర్వ్ చేసినట్లయితే డయాగ్రామ్ m of t less than 1 condition, we have the perfect envelope shape. The am amplitude Ka m of t is greater than 1 for any t, then the carrier wave becomes over modulated. Then the carrier signal becomes both the positive and negative, and both are directed this type. These are over modulated here. Maximum value on the K of m of t envelope multiplied by 100 is called percentage modulation. The carrier frequency Fc is much greater than the highest frequency component W of the message signal m of t. Carrier frequency is much more greater than the W frequency component. W is the frequency component. This is the first topic of amplitude modulation introduction.